The next topic is the classification of the flow. Okay, I forgot from the previous lecture. The other thing is the operational flow is turbulent flow, so we have to consider the turbulent flow only. Okay, and for the classification of the flow, we divide into groups. First is the steady flow and unsteady flow. So for the steady flow, we can say that this is a constant with time. In this case, mean the depth and velocity of the flow. I can say the depth and velocity of the flow is constant with time. And there are two subs divided to. First is the uniform flow. Okay, uniform flow is mean the depth of the flow is equal along the profile. Okay, and the other thing is valley flow. A valley flow, we can say another one we can say is non-uniform flow. So it means the depth of the flow is vary along the profile. And for the valley flow or non-uniform flow classified into the gravity valley flow, we can write the short it gravity valley flow and rapidly valley flow. And for the unsteady flow, we classify in the first is the unsteady uniform flow. That is a rare the phenomena. Okay, and the second is the uniform unsteady flow. We can say that the unsteady flow can be that this condition is mean it's chain with time. So what change is depth and velocity of the flow changes with time. And for the unsteady flow is classified to the gradually valley flow, unsteady flow, and rapidly valley flow, unsteady flow. This shows how it looks like in terms of the profile of water. In this case is the uniform flow. Okay, so it's just the depth. The depth of water is constant, and so the velocity, depth and velocity is constant. The velocity is constant and depth is constant along the profile. Okay, and for the next is unsteady uniform. So we expect that if the time changes, for example, it's T1, T1 and T1. Okay, the depth of water increase to the next when time increase, the depth of water increase. So it means they can see that y like this. Okay, so this we call the unsteady uniform flow. But uniform is mean still the depth is the same along the profile, so we call the uniform, but the depth is changed with time. Okay, and this picture shows the non-uniform flow. Or the vary flow. Okay, so we have two classifications: the rapidly or gradually vary flow. So under the switch gate, this is rapidly vary flow, and after this is gradually vary flow, and hydraulic jump is the gradually rapidly vary flow. Okay, and flow over the weir is the rapidly vary flow, and the hydraulic drop is rapidly vary flow. And the last one is the unsteady flow. Okay, this is a gradually valley flow. It's a flat wave to show the gradually valley flow, but this is a very what we call the ball. It's a rapidly vary flow. So in the detail of the steady uniform flow, we can say that for steady uniform flow, the Q, the discharge is constant, the flow depth is constant everywhere along the length of the channel. We call that normal depth, and it occurs in every long inclined channel of constant cross section, and heat loss due to the turbulent flow equal to reduction in the potential energy. For the steady non-uniform flow, the one property is that Q doesn't change with time, okay, and occur in any irregular channel, occur in a regular channel with the when depth and velocity change from one cross section to the other cross section, and gradually change in depth or section we call the gradually vary flow. And the fourth is the change in velocity and depth in a short distance we call rapidly vary flow, okay, or for example hydraulic jump. For unsteady non-uniform flow is a rare phenomena in operational flow, and for unsteady non-uniform flow is common but is difficult to analyze wave motion, positive and negative surge wave. Flow can be also classified into the tranquil and rapid. Okay, for tranquil flow is mean the calm and peaceful flow, and foot number is less than 1. Okay. In this case is low velocity, small disturbance can be travel upstream flow is controlled by downstream condition. We call that subcritical flow. We can draw like this to explain. This is a flow or profile of the superchannel flow. If there is some disturbance, like the depth of water is increased, for example this, and increase, so we expect that there is the water surface can be disturbed by this. Okay, for this is T1. Okay, if the so in this case is controlled because the can be travel upstream, so can be the effect is travel upstream and is controlled by our downstream condition for the in first case. And for the second case is the rapid flow. Foot number is greater than 1, so it's kind of like this. So this term, the depth water increase. For the rapid flow, everything the same, can be like this. Okay, so if the flow is moving very fast, there's nothing change upstream, but it's changed downstream. So this is in the case number 2, rapid vary flow. So it means a small disturbance, small change in downstream condition does not affect any change in upstream condition. Flow is controlled by upstream condition. We call that supercritical flow. Okay, and the third case is the critical flow for number equal to 1. For the velocity distribution on the open channel flow, the velocity is at the solid boundary it should not be 0. If we draw the flow velocity in the, you can draw like this. If you measure the velocity along depth, Okay, flow like this. So the first is at this point. Look at the solid boundary is 0, so V is 0 at this point, and velocity increase with the distance from the boundary. For the open channel flow, this is water surface, this is a surface, and the maximum velocity is not on the surface. It's about something a certain length from the bottom. The maximum velocity is not at the top of the not at the water surface, but at some length from the bottom.